Hello everyone, let us take one example on inverse Z transform. For example, if x of z is equal to, let's say, 3z inverse upon 1 minus 2z inverse into 3 minus z inverse. Let's say we have to find out inverse Z transform. That means we have to find out x of n for the given Z transform. I can first expand the denominator factors. If I expand them, that means if I multiply the two, I get 1 into 3 will be 3. This will be 3 into 2 minus 6Z inverse. And here you will have minus Z inverse, that will make it minus 7Z inverse, and plus you will get minus plus 2Z inverse. And if I convert everything into positive power of Z, which is something I should do, it will become 3Z upon 3Z squared minus 7Z plus 2. So this is everything in the positive power of Z. How will you do that? You have to, this will be Z raised to minus 2 because 2z inverse and z inverse will give you 2z raised to minus 2. So you'll have to multiply numerator and denominator with z squared. So if I do that, z squared into z raised to minus 1 will become z. 3z squared minus 7z raised to minus 1 into z squared will be minus 7z, and z square into z raised to minus 2 will become 1, so we'll be left out with 2 here. Once that is done, we should always bring Z transform in the standard form. Now what we mean by standard form? The standard form says that the degree of the highest power in the denominator should be equal to 1. So for that to be possible, I'll take 3 out as a common term. So I'll be left out with z square minus 7z. So this will become 7 by 3z plus 2 by 3. I've taken 3 out and it will cancel out with this numerator 3. So the overall Z transform becomes Z upon Z square minus 7 by 3Z plus 2 by 3. Now once you get this, so we had to go through couple of steps to everything in positive power of Z and to make the coefficient of the highest power equal to 1. Now once that is the case, I can now, if possible, factorize the denominator. So you can see denominator can be factorized as Z minus 2 into Z minus 1 by 3, minus 2 and minus 1 by 3. This will be the two factors that we have. This you can verify easily. And now let us go to the next step where we will discuss inverse Z transform. To find inverse Z transform, we will first have to perform something called as partial fraction expansion. And we do not perform partial fraction expansion of x of z. We rather perform partial fraction expansion of x of z by z. You will see the reason later on. So I'm dividing z on both the side, dividing by z on both the sides. So x of z upon z, and when you divide by z, z will cancel out, so it will give you 1 upon z minus 2 into z minus 1 by 3. And now I will do partial fraction expansion. So partial fraction expansion gives me x of z upon z. This will be equal to a upon z minus 2 plus b upon z minus 1 by 3. I'm sure all of you must have gone through partial fraction expansion before, so I leave the solving as an exercise for you guys. If you solve this, you'll get a equal to 3 by 5 and b equal to minus 3 by 5. So finally your x of z by z becomes, a becomes 3 by 5 upon z minus 2 and b becomes minus 3 by 5 upon z minus 1 by 3. And now I'll send this z on the other side once again. So that gives me x of z equal to, I'll keep this 3 by 5 out. It becomes z upon z minus 2 minus 3 by 5 into z upon z minus 1 by 3. That's the simplified x of z that we were looking for. And now I can apply the inverse Z transform formula. That is simply because you can see z upon z minus 2. So see, we wanted this z in the numerator, and that's the reason we send it on the left hand side by dividing by z first, so that after partial fraction expansion I can bring it in the numerator. And why do we want it in the numerator? Because z upon z minus 2 is nothing but a standard form of the Z transform. So is z upon z minus 1 by 3. That's because we had already got z upon z minus a as one of the Z transforms. And if you remember, what was its inverse Z transform? Its inverse Z transform was nothing but a raised to n u of n.